In this video, we are going to look at how to design documentary display on Protues and simulate it on Protues using 8089C52 microcontroller. This is the circuit on Protues already drawn. We make the connections using wireless, that is, we use normal connection port, output port, and input port to make the wire connection. They are connected. And this is the 8051 microcontroller, 8089C52 microcontroller. This is the microcontroller that we bounce the code in it. Then it takes care of every other thing. This is the basic configuration. What you basically first of all do before the 8051 microcontroller will start working, you must configure it in this way. Then we have another IC called latch or shifter. It receives input from the microcontroller and sends it to the documentary display. The name is 74HC573. It receives from the microcontroller and sends to the documentary spot. This is the documentrix. Here we have 4 pages, and the page of the display is determined by the number of the shifter IC. We have 4 pages, so the number of shifter IC we will have is 4 also. Look at it. Connection is wirelessly, that is the output. Whatever we have in that terminal, when we on it, you will get it at the other terminal at the display. Whatever we have in the next one, as long as you give them the same name, they are connected in the software. Whatever we load from the microcontroller will remain on the buffer memory of the shifter IC until we send a high to low pulse on this particular terminal, that is the latch enable. When we send a high to low pulse on this particular terminal, it will now move data from the buffer to the output and then send it to the display, the documentary board. We have 4 of the shifter IC here. That is makes it the 4 ports. Whatever we send, and we use it to determine the particular page we want to display information on. When we load information on this data line and clock this particular latch enable for this, it will now display on the page that this one is controlling. The same thing with the other one. Once we load something on the data line and clock the latch pin of the IC we want to display on its page, it will now display it on that particular page. This is the 4 shifter IC or latch IC. We have also 4 dot matrix board. Then this dot matrix board, the columns are connected to the latch shifter, while the rows are being driven using TIP41C transistor. As we are sending a high to low pulse on the transistors, it will be on each of the rows one after the other, one after the other. With that way, based on the speed, you will think that the test is moving, but we are just on and offing the rows at a particular time. The whole rows A to H, it has from A to H terminal. The whole A are connected together to one transistor. The whole B are connected together to one transistor. The whole C are connected together to one transistor. That's why we have how many transistors here? 8 transistors. That is based on the number of rows we have on the dot matrix. From A to H, we have 8. So that's why we have 8 transistors to drive each of them one after the other. These are the connections you have to make before you will simulate this particular project documentary display. You get it? Look at the transistors, the way we connect them. Now, I'm going to show you how those wireless pin connection, how it works. Maybe for the people that are not close to Protues or that does not know how wireless connection works on Protues. I'm going to do a little practical now to show you a little simulation to show you how the particular wireless pin connection works, how it behaves. Okay, let me show you how it works. This one is the this one is the receiver, while the other one is the sender. That is in actual sense, this one is the output, while this one is the input. Okay, let's label it. Let's label it very well. That's good. Okay, this one is the output, while the other one is the input. Let's run a little simulation on it for you to see how it works wirelessly. I will give them the same number. Let's say I call them G. You see it? I will write the other one, I will name it G. Automatically, they are connected. Let's connect an LED on it and use a logic probe to on and off that LED to see how they works. Because they are connected together, any information I'm sending from the output, the input will receive it. Select a logic probe. Okay, a momentary latch and an LED. Okay, let's connect the LED. Yeah, we connect the ground. Okay, let's connect the momentary logic probe. Okay, let's now on. Once we play it now, look at it, we have 0 here. Once we turn this one to 1, it will on. Look at it. Once this one becomes 1, the LED will on. They are now connected. That is how we make the connections on that automatic side. That is the exact way we make the connections wirelessly. You don't need to draw the threads from this one to the other one. No, 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 no. You just use this wireless connection and you get exactly what you want. Okay, let's go back to the circuit. That is exactly where we connect everything to the terminal. You understand? Okay, let's now go down to the program that runs in the circuit. The program was this. I wrote the program using a assembly language. My port declaration, I call letter one, I display, you call the second letter, you display. When you call fast. That fast now has a particular place I define what it is. Okay, this place now, it will repeat this fast 8 times. As it's repeating it, it's shifting the information. What I mean by shifting is that what we have in this particular memory is sending it to another memory. What we have in this memory is sending it to the other memory. Let's look at what happens here. Okay, let's go down to that shift. Okay, this is the memory. What we have on this particular memory, it moves it to the other one. What we have here, it moves it. That's the way it moves it. So when you are not looking at those things, it will not look as if that the text is moving, but we are just transferring the information from one memory to the other, from one memory to the other, and it looks like that the text is moving on the display. That is the basic, that is the secret about dot matrix. You are just loading the information from one memory to the other, from one memory to the other, from one memory to the other. This is where we define the whole alphabet, numbers we are displaying, special characters, column, whatever character we want to display. This is the place we define all of them, all in assembly language, a low level language. Let's assemble it. There's no error. Immediately we assemble it, it have generated a header file. And that header file is what we are now going to upload to our Protues code. Okay, we open the microcontroller, we upload that code. name it 4 digit, 4 page. Then let's play and see what happens. You look at it, it is playing, you see it. This is the test, Casino Digital. This is the test we are displaying. You can see it. You can see how the communication are moving. When you load from the microcontroller will load. When you load from the microcontroller to the latch shifter will wait until you clock the latch enable pin before it will now move that information to the output. And that output now will now display whatever you've loaded to that particular memory or to that particular latch on the dot matrix display. You can see it. This is the way you would design a dot matrix display on Protues and simulate it. If you construct this project in real life, it will work perfectly the way we designed it here. Everything will work as designed. Are you getting it? That's the exact way you do everything. This is the code that runs on it in assembly language. Then every other thing has been taken care of. At the end of this lecture, I will give you a link where you will be able to download this code. When you download it, both the header format, both the assembly code itself and everything is the format. You download it and upload. Thanks for watching.